Hello all. This video talks about mathematical expectation. There are going to be two expected values that are more frequently used to characterize any random variable. The most often used are the two expected values which are most probably helped to define the nature of a random variable are referred as mean of a random variable, which is denoted by mu x, and the second quantity that defines the nature will be variance of the random variable denoted by sigma square of x. Now here the denominator we have a letter called as x, which says that it is the mean of the random variable x and the variance of the random variable x. So these two quantities, mean and variance, more frequently used to characterize any random variable x. Now we will see how we can evaluate or estimate the values of this mean and variance. The mean of a random variable, also called as the expected value of a random variable, expected value of the random variable is denoted by E of x and denoted by the script mu x. It refers to mean, the expected value, also at certain times referred as the average of data, is given by summation of xi pi, summation running over I, where capital X is going to be a discrete random variable, and the same expected value or the mean is defined as integral over the range space x into f of x dx when x is going to be a continuous random variable. Now, what is the difference we notice between the definition of a PMF, a PDF, and this expected value? The extra x which is present over here, that is getting multiplied with each of the probabilities before you add, gives the difference. So, how to estimate the mean? The corresponding random variable into its corresponding probabilities addition. So the random variable f of x function with multiplication or the product with x and then the integral of the datas gives the expected value called as E of x. Next comes variance of x denoted by sigma x the whole square. Now this is defined as expected value of x minus the mean mu x the whole square. So it is the expected value of the deviation of the random variable from the mean the whole square. And how can you write this for a discrete data? It is summation xi minus mu x the whole square into the corresponding probability pi for a discrete data. And for a continuous data, how will you write the same as? It is integral xi minus mu x the whole square into the function f of x dx over the range space Rx. So this seems a little tough for the computation. So when we expand this using a minus b the whole square formula, this further get simplified as E of x square minus E of x the whole square. So our formula for variance of x now takes the format of E of x square minus E of x the whole square. So what is E of x here? E of x is summation xi into probability of xi for a discrete data, or the same is x into f of x dx for a continuous data. And this now defines the second term E of x. Now what about E of x square? So how to estimate this value? So it is the summation of, now in place of x I have x square. So in place of x I will have xi square into probability pi for a discrete case, and the same is integral x square into f of x dx for a continuous case. Hence, instead of the last one, we will frequently be referring to this formula of variance of x, which is given as E of x square minus E of x the whole square. Now, let us move to see properties of your mean and variance. So, properties of mean and variance. This will technically help us to solve mathematical problems very easily. So, the first property is property number 1. If you have C to be a constant, then expected value of a constant is the same constant. So, whenever I take expectation of, say, the number called as 100, so what it is returned as? It is returned as the same 100. Okay. The second property says, if A and B are going to be constants and x is going to be your random variable, then expected value of Ax plus B is, being expectancy operator being linear, gets split as E of Ax plus E of B. Now we know that expected value of a constant is constant, and when it is multiplied by the random variable, this can be treated to be independent, and so you will have it as A times E of x plus, and what we know about E of B? E of a constant is a constant, so we will have it as B. So for example, expected value of 3x plus 4. What will this be equal to? It will be 3 times expected value of x plus 4, because E of 4 is 4. Now comes the third property. Third property says that variance of a constant C is always 0. Why is this so? Because we know that the variance is given by the formula E of x square minus E of x the whole square. So when I take the constant, whether it is E of c square or E of c the whole square, a c square and c square gets cancelled off and results in 0 when this is going to be a constant. So variance of a constant is always 0. So what can you say about variance of 5? Variance of 5. Variance of 5 will always be equal to 0. Variance of 5 will always be equal to 0. Variance of any constant for that sake will always be equal to 0. Property number 4. Variance of Ax, where A is a constant and you have x to be the random variable, will be equal to A square times variance of x. A square times the variance of x. This is because the variable gets squared over here before the subtraction, and hence you will have it as A square times variance of x. And property number 5, variance of Ax plus B, where A and B are going to be constant, then you have this as, so you can split it as variance of Ax plus variance of B. And what do you know about variance of Ax? It is A square times variance of x. And what we know about variance of B? B is a constant. We know variance of a constant is 0, so this will be plus 0. So it just returns you A square times variance of x. So when we have problems, either it is going to be a discrete random variable or a continuous random variable, we can apply these property effectively to get the values for mean and variance.